Hello guys, and we are back. Ooh, I want to get these off. My reading glasses, don't need those. Alright, not for you guys. Got you set. Alright, so I want to talk for a minute about 11.3. I want to talk about slope. And you'll find this in your exercise set 11.3 in your My Math Lab homework. So we're moving on and talking about the slope of a line. Notice here, the slope. One way to think of a slope is the slant of a line on a graph as we look at that line, how it moves from left to right. So for example, I've got a graph already written up here for us. For example, if we have a line that slants like so, as we look at this from left to right, this line slants uphill. Okay? Uphill slant, otherwise known as a positive slope. This line slopes upward from left to right, a positive slope. The slope will be quantified with a number, actually as a fraction, and when we see lines like this, we're expecting a positive number for the slope. Of course, if we have a line that does this action, as we look at it from left to right, this is a downhill slant. As we're looking at this line right here, and we look at it from left to right, it's going downhill from left to right. Of course, that, there I am, yep, hey, that would be a negative slope. Alright, so we have a positive slope and a negative slope. There's a couple of other slopes that we'll take a quick look at as well. I want you guys to know about. Let's just take a quick look. If we have a line on a graph that doesn't go uphill, doesn't go downhill, that baby is just flat. It's a flat line. If it's flat line, it has a zero slope. Flat has zero slope. Okay? And let's do one more. If we have a line on a graph that goes straight up and down, okay? Doesn't slant uphill, doesn't slant downhill, certainly isn't flat, but is just a straight vertical line. This is what we call an undefined, U-N-D-E-F-I-N-E-D, undefined slope. So for quick looks at possible slopes, they could be positive, uphill. They could be negative, that would be downhill. They could be flat, that would be zero. They could be undefined, that is a vertical line. I want to show you another way to look at slope as well that I think is very interesting, very important. You know we've graphed lines up to this point. We've had points on our lines. Okay, so look at this with me for a second. Let's say we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, ooh, let's see if we can get that evened out a little bit. 1, 4, 5, 6, 7, 8. Oh, lost my light. I'm back. Funny place. The lights go off so easily. Anyway, we're talking about slope. Let's get back on track here. Talking about slope. All right, let's say we have a line on this graph. Let's get a couple of points. Of course, these are ordered pair solutions to some equation. We don't know the equation. It doesn't matter right now. We just need to know we've got an ordered pair solution and a line here. So we'll make 3, 2. 3, 2. All right, there's a point. All right, that's an ordered pair solution to some equation. I don't know the equation, but it doesn't matter right now. All right, let's get another point. This point would be maybe 1, 5 right here. 1, 5 right there. Let's draw a line. Beautiful. 1, Wonderful. All right, so here we go. We have a line. It's obviously a positive slope or a negative slope. What do you think? Kind of looks downhill. Must be a negative slope. Must be a negative slope. All right, so when we look at this slope and we see these numbers here, another way I want to describe slope, another way to kind of define slope, slope might be how we get from one point to another point on a line. In other words, how do we get from this point down to this point? How do we get there? How do we get from here to here? Well, I would suggest that what we do actually to get from this point to this point is we come from the point out a little bit till we get lined up directly over the point underneath. So we come out and get lined up directly over it. And then we drop down to it. So out and then down. We come out a little bit and then we get lined up and we come down a little bit. And that's how we get from that point to that point. Well, this out and down business, that actually has some names attached to it. All right. Another way to see slope is the slope of a line is the line's rise over its run. In other words, to get from this point to this point, we run a little bit, and then we drop a little bit, which is actually a negative rise. We don't go up, that'd be a positive rise, but we come down. So when we look at this line right here, notice what happens. We're right here, and to get lined up directly over that next point, we'll have to come one space, two spaces over. All right, so two spaces over from here to here to get lined up over the top, two spaces over, a run of two. Now, when we come down, we've got to come down 1, 2, 3 spaces. Down 3, that's a negative. Wow, my slope for this line, if I just counted it correctly, is negative 3 over 2. Negative 3 over 2. That's just counting a slope. Now, the other thing I want you to notice that a lot of folks use with slope that's pretty good is this idea that we can have our slope equal the subtraction of the y values over the subtraction. Why don't we just say subtract? That'd be even better. Subtract the y values over subtract the x values. All right. Notice this. Notice this now. Subtract this. This is an x value. This is a y value. This is an x value. This is a y value. Notice what happens here. 5 minus 2. Oh, let's do it the other way. 2 minus 5, negative 3. 3 minus 1, 2. Cool. All right, let's see how that plays out actually with these 2 points. I'm just all over the place with space here, but bear with me. It's going to be okay. Remember, we're going to say our slope equals, we're going to subtract our y values, 2 minus negative 5, okay? Oh, sorry, 2 minus 5, what a negative 5? I know I probably confused you on that one. Catch up with me. All right, so 2 minus 5, y values, and then 3 minus 1. We want to make sure when we go 2 minus 5, when we go from this point, subtract this point, we also want to go in the x value with this point, subtract this point. In other words, do not go 2 minus 5, and then go 1 minus 3. Whatever direction you go in, continue that direction. 2 minus 5 over 3 minus 1. Now you could have gone 5 minus 2 over 1 minus 3, and you'd have the same answer. But we end up with a slope, of course, of negative 3 over 2. When we counted it, we counted a run of 2, we counted a rise of negative 3, and that gave us a slope on the count. And then when we used the slope formula, we were able to subtract the y's and subtract the x's and have our slope. Well, guys, that's all I want to show you on slope right now. You should be able to jump in and do a little bit of the homework with that. Do that well, and I'll come back and talk to you a little bit more next time about maybe some more slope. See ya.